Okay, so this is just another form of substitution. We don't simply have, x equals 11 like we did in the first one. If you haven't watched the previous video, definitely go back and watch that one. In this case, we have a system of equations and both are in the y equals mx plus b form, which is slope-intercept form. So we can see that down here. We have y equals 7x minus 21, y equals x plus 15. And these are definitely very easy to graph. Relatively, because we're going to have to go to negative 21 for the y-intercept on this one and positive 15 for the y-intercept on this one. So definitely would need a much bigger graph than we're used to using. So in this case, we can also just understand that they both, in fact, equal y. So I'm going to write it over here so you can see this. So the first one, I flipped this around, so I put y on the right side instead of the left side. That does not change anything, because we know that y is the same as 7x minus 21. That's what equal means. They are the same thing. I can interchange 7x minus 21 and y. Well, I also know that y is the same thing as x plus 15. They told me that in the second equation. So I can interchange y for x plus 15, or I can interchange it for 7x minus 21. Well, if I can interchange y for either one of these expressions, the expressions must be equal to each other because y is equal to y, right? So instead, I can just kind of skip this middle section and just bring the two equations together. I can substitute them together, right? I can interchange this y for 7x minus 21, and I can interchange this second y for x plus 15. I can substitute them. So this is kind of a double substitution. It's another form of that. So now that I have them together and I only have one variable, I can solve for x. And what that will tell me is where do they cross? What's the x coordinate for where these two lines cross? So I'm going to subtract x from both sides because I'm going to bring my x's together. And really, I just chose that first step when it's in this form where you have a variable on both sides and a constant on both sides. Just choose one to start with. It doesn't matter which one you choose. You just start bringing like terms together from one side to the other. So I, by chance, chose the x. And I get 6x on this one because 7 minus 1. And then the 21 drops down. The x's cancel. X minus x is 0. And then the 15 drops down. So now I still want to get x by itself, and since they're all on the left side, I'm going to pick on this 21 here. It's negative 21, so I'm going to add 21 to both sides because that's the opposite. Negative 21 plus 21 cancels out. They're opposites of each other. That's the whole point of this opposite operation. So 6x drops down, and we get 15 plus 21 is 36. So now my last step is to deal with this 6 times x. The opposite of times is divide. So I'm going to divide both sides of my equation by 6, and I get x equals 6 because 6 divided by 6 cancels, and 36 divided by 6 is 6. So now I have part of my answer. If you notice, I only have one of them. I need to go back and find my y. This just tells me on the graph, the two lines would cross at an x coordinate of 6. So I know I'm going to go to the right 6, but I don't know where, up or down, they're going to cross for y. I need to figure out the y coordinate. So I'm going to pick either one of the two equations, and I'm going to plug it in. So for whatever reason, I like this one because it just seems a little easier. They're both, not too bad. 7x minus 21 is not all that much more difficult than x plus 15. The only difference is here I'm just going to simply add 15 to whatever x is, which I know it's 6. This one I have to multiply and then subtract. So for whatever reason, I just picked the second one. So I have 6 plus 15, and I get 21. So it's going to go... These two lines would intersect at 6, 21. So I'd go right 6, up 21, and that is where they would actually cross. Okay? So I would get the exact same answer if I multiplied 7 times 6, I get 42, and then if I subtract 21, I get 21 again. So either equation I plug it into, I will in fact get the same solution. That is definitely something that you can check, because if you get a different solution for one equation than the other, something went wrong over here. They should be the exact same solution because they should only cross at one point. As long as they don't have the same y-intercept and the same slope, they definitely should be independent lines. So, all right, I hope that helped. That's another form of substitution, and I will see you in the next video.